Hello students, welcome back to my YouTube channel Neon Crackers Cracking IIT and NEET. In the last video we have discussed about hyperconjugation and its applications. Hyperconjugation and its applications. So what is actually hyperconjugation? There would be some sp2 hybridization. So with respect to sp2 hybridization, alpha sp3 hydrogen should at least one alpha sp3 hydrogen should be present. Actually what is happening here? sp2 hybridizations, it is having planar geometry. Now one free orbital is there which is like pz orbital. So if you have any ch bond alpha position, now here sigma is converted to c minus and h plus. So this c minus lp is donated to adjacent empty orbital which is all like pz orbital, right? So this is simply called hyperconjugation, is nothing but what? Delocalization of sigma and pi electrons. Delocalization of sigma and pi electrons. If we observe two effects like hyperconjugation and inductive effect in a single molecule, always hyperconjugation is more effective than inductive. What is the reason here? One of the bond is endothermic reaction, another bond formation like pi bond formation is what? Exothermic reaction. At least one exothermic reaction is present in hyperconjugation, but wherein inductive effect we have only polarity of sigma bond which is a stronger bond. So that polarity of sigma bond is what? Exactly endothermic reaction. That's why it is somewhat less effective. Of course, after discussing all the effects, out of all, inductive is the least effective part because it is a polarity of sigma which is a stronger bond. So that is a concept here. Now applications are over already. 2-3 applications like carbocation stability, next one is carbon radical stability, next one is alkene stability based on a hyperconjugation. Let's see remaining parts of the applications of hyperconjugation. So next one is what here? Bond length. Another application is what here? Bond length. So actually what is a bond length? Bond length, there are three factors, like many trends are there, we have to follow some sequence. That sequence I will teach you in chemical bonding. Actually overall what is a bond length definition? So the internuclear distance between two connected atoms is called what here? Bond length. Maybe it is ionic bond or covalent bond or coordination covalent bond, whatever the bond it is, the internuclear distance between two connected atoms is what here? Bond length. So first factor of bond length, is what better here? First factor is size. Size is a matter. Apart from size, next one is what here? Bond order we have to choose. Bond order, more bond order, less bond length, because stronger bond order, so here strongly overlap. Now it is giving what here? Lesser bond length, which is closer to each other because of strong bond order. Next, last one is what here? Hybridization. Among hybrid orbitals, of course, among hybrid orbitals here, sp, sp2, sp3, sp2, sp3, three conditions are there here. Now sp3, yesterday I have given this sp2, sp3. sp3 is what here? More s character, more penetrated towards what here? Nucleus. So whatever here, stronger sp is nothing but what here? Stronger internuclear attractive forces are there, which means here these are strongly overlap like this. So bond length, what happened with the bond length will be decreased. So that is among hybridizations we have to check it here, sp, sp2, sp3. Now the same concept if we apply in hyperconjugation, what will happen? Let's see one example here. First one is CH2 double bond CH2. What is it? What is that? CH2 double bond CH2. Second molecule is a CH2 double bond CCH3. Methyl group is present. Next one, third one, CH2 double bond CH3. So two methyl groups are present. Now here you may observe one effect. What is that? Hyperconjugation. What is that? Hyperconjugation. First one, there is no hyperconjugation. First one, of course, there is no hyperconjugation. There is no what here? Inductive effect also, because there is no polarity, non-polar nature like this. Everything is what here? Something what a non-polar nature. Now here, so you may observe what? Hyperconjugation. Hyperconjugation, how many hyperconjugative structures are there? Total number of hyperconjugative structures are nothing but here 3 alpha hydrogens plus 1. Total 4 are there. 4. Next here, how many alpha hydrogens? 6 alpha hydrogens plus 1 individual, that unique structure is there. So total here 4 structures, total here 7 structures. That is okay. According to hyperconjugation, this one is more stable than this one is more stable than this one, that we may find easily, that is okay. Now here, what is the application? Bond length. What is the application of bond length? Which bond length? Bond length between CC. Bond length here, bond length between this one, this CC, this C double bond C bond length. Next here also in between these two bond length, what happens? Next here also in between these two bond angle, what happens? That bond length, bond length we have to consider here. Bond length. Now first one is there is no hyperconjugation, which means first one is having exactly C double bond C. Bond order equals to what here? To exactly one pi bond is present between these two carbons. Now here what is happening? According to this hyperconjugation, what is happening here? This hyperconjugation, what is happening? Maybe it is what is a hydrogen removal, what is the charge beta? C minus. Hyperconjugation application, it is delocalized. So what is the charge here? C minus C double bond CH2. Now actually we are finding the bond length between these two atoms. So what is happening here? Because of hyperconjugation, the double bond is being converted to what here? Single bond. Double bond is being converted to what here? Single bond. But how many times? Depending upon the number of alpha hydrogen. With respect to one hydrogen, one time single bond. Next remaining two hydrogens are there. Overall 3 times we are getting what? Single bond. 3 times we are getting what? Single bond. In the same manner here, how many alpha hydrogens we have? 6 alpha hydrogen, which means you may get 6 times CC single bond. 6 times CC single bond. Of course, one thing we know here, bond order, bond length relation. Bond order, bond length relation. So bond order is inversely proportional to bond length. Bond order is inversely proportional to bond length. Now actually bond length, what is the order among what is the carbon-carbon bonds? So bond length, first one, CC single bond is greater than CC double bond. CC double bond is greater than CC triple bond. This we know because here more bonds are there. So internuclear distance is very less, and now bond length what happened will be decreased here. Now this CC single bond is having maximum bond length among all double bond, multiple bonds. Now this is exactly double bond, and this one, this carbon, these two carbons are getting single bond, that is okay. But how many times single bonds? 3 times only. Here it is getting CC single bond, but how many times? 6 times it is getting what here? Single bond. So more times of single bond, it is elongated like this. So bond length, what happened? Bond length, what happened here? It will be increased. Bond order will be increased. That's why here, out of all these 3, which is having the maximum bond length? Maximum bond length. First one, this is 6 times sigma, single bond as sigma bond. Here next molecule is this one. This is 3 times CC single bond. And this one is, there is no CC single bond. 100% CC double bond. So more bond order, less bond length. Less bond length. So this is the order. So it is very important application in hyperconjugation. Like this we have to assume here. Now tell me what is the shortcut here? Bond length and double bond. Of course in alkene what is the relation? If you have more number of alpha hydrogen, more times you may get what? CC single bond. If CC single bond is there, now bond length is what here? Increased. So here bond length is directly proportional to number of alpha hydrogens, number of sp3, that is sp3 hyperconjugate to alpha hydrogens. Bond length is directly proportional to number of alpha hydrogens, So this is very important, number of alpha hydrogen. So one more application of this same thing. Now you have to find, tell me the answer here. CC, only CC is there. Here C is there. Next one here C, carbon is there. Next one here C double bond C, carbon is present. Next one here C double bond C, carbon is present like this. Now find out the bond length. Here how many alpha hydrogens? Here 0 alpha hydrogens. Here how many alpha hydrogens? 3 alpha hydrogens. Here how many alpha hydrogens? 2 only. There are only 2 alpha hydrogens. So 3 hyperconjugative means alpha plus 1 unique structure. 3 hyperconjugative structures. Anyway, 2 alpha hydrogen, right? Now here how many alpha hydrogen? 1 alpha hydrogen. Now here how many alpha hydrogen? 0. Here 0. Now tell me here, maximum bond length. Which one maximum bond length? Maximum bond length equals to number of alpha hydrogens. Number of alpha hydrogens. So which is first here? What is the order? What is the order here? Which is first? Right? Which one better? This is having what? Maximum number of alpha hydrogens. So more times you may get what here? CC single bond. CC single bond is what here? Maximum bond length. Second here 1 alpha, 2 alpha. So 2 alpha may get what? More bond length. Third one is what here? This one. Now in between these two. I mean here we are comparing what? Not carbon, all the carbons. Here only this is our targeted carbon. This is our targeted carbon area. Now what is the bond length here? Nothing is there. Here what is the bond length here? What is the effect of carbon here? What is the effect of carbon? Carbon effect is what here? Plus I effect. Due to plus I what happen here? Due to plus I what happens? Due to plus I what happens here? Electron density is increased. Electron density is increased, which means your S character is increased. S character is increased. Then penetrating capacity is also increased. So in between these two, this is having the least bond length, which means here 1, 2, 3 over. Next one is what here? This one will be the fourth one. This one will be the last one. Fifth one. So this is the order of bond length. How to apply hyperconjugation? Hyperconjugation effect in bond length. Hyperconjugation effect in bond length. So now you have to choose like number of alpha hydrogen, how many times you are getting CC sigma bond. So that is a matter of this hyperconjugation bond length application. Is it clear, beta? Bond length applications. Anyway, it is depending upon which one? Depending upon which one here? Number of alpha hydrogens. Number of alpha hydrogens. Next one, that I effect bond length is also there. I effect bond length. For example, CCH is there. Next one is C double bond CH is there. This is the CH bond length. CH bond length order. C triple bond CH is there. So this is the CH bond length. Here in between C and H. C and H here we have to compare. Okay. This is the bond length we have to choose. This bond length we have to choose. Here this bond length we have to choose. Now what is the hybridization of this one, beta? sp3 hybridization. Here what is the hybridization? sp2. Here what is the hybridization? sp. So sp is having what here? More s character, less bond length, more internuclear distance, more z effective. So due to z effective, it is getting what here? Compressed like this because of here z effective. It is like slighter compressed. Next it is nothing happens because extra plus I is there, no problem here. Out of all which is getting compressed more here, this bond is getting compressed because of sp carbon. So more compression, bond length what happen will be decreased. That's why here this is the 1, this one is the 2, this one will be the third one. So this is the bond length. So bond length means what kind of bond they are asking, that is important. Maybe CH bond or maybe CC bond. Maybe sometimes here also they may notate like this, right? This bond we have to compare or this bond we have to compare. So choose the factors. Which is the effective factor? Based on that effective factor, so we have to find the trend of bond length. So this is the overall application of bond length. Hope you understood it. Hope you understood it, right? Check it once. Next application of hyperconjugation. Next application of hyperconjugation is heat of hydrogenation. What is it, beta? Heat of hydrogenation. So heat of hydrogenation. Heat of hydrogenation. So it's only for, of course, it is a hyperconjugative application, but applicable for alkenes, not for radicals, not for carbocations, not for carbocations. Heat of hydrogenation is simply a reduction reaction. For example, here one alkene is there, one CC double bond is there. So hydrogenation in the presence of any catalyst like palladium, platinum, whatever, you make it what here? Alkane. You make it what here? Alkane, addition of hydrogen, right? So this is what here? Addition of hydrogen. Addition of hydrogen is always exothermic reaction. So it is a what here? Exothermic reaction. Liberation of heat to the surroundings. Liberation of heat to the surroundings. Now here matter heat of hydrogenation. More amount of energy is released, which means here if this reactant is unstable, now it converts to easily what here, stable molecule plus by releasing what here, energy, releasing energy, that is what here, more energy. If it is unstable, so converts to stable and giving what, more amount of energy to the surroundings, more amount of energy to the surroundings, which means here potential energy what happen beta, it will be decreased. Potential energy what happen here, decreases. That's why lower potential energy is called what here, stable products, which is if it is unstable, this is unstable. So here what is the factor we have to consider, what factor we have to consider here, heat of hydrogenation, what factor we have to consider, stability of alkene, which means here for one example here, stability of alkene, I mean stable alkene is a stable, already it is stable, then heat of hydrogenation, I mean that hydrogenation reaction is less or more here, it is less reactive, if it is less reactive, then the amount is also less, the liberation of amount to the surrounding is also what here, less. If it is unstable, if reactant is unstable, which means alkene is unstable alkene is there, so it is more reactive, so it gives what here, more amount of energy. Of course here some product is formed, that is alkane, and more amount of energy is released, actually that less energy, more energy, whatever, this is called what here, heat of hydrogenation, del H, heat of hydrogenation. Now tell me what is the relationship between stability, heat of hydrogenation, stable alkene, less amount of energy released, right? Yes or no? Next one, unstable alkene, more amount of energy is released. Now overall what is the funda here, stability, I mean not stability, so heat of hydrogenation is inversely proportional to stability, right? Which means here heat of hydrogenation is inversely proportional to hyperconjugation, because hyperconjugation and stability is directly proportional relationship. So overall what is the theme here, heat of hydrogenation is inversely proportional to hyperconjugative structure. So this is the phenomena of what here, heat of hydrogenation. Alkene, if it is unstable, readily undergoing what, reduce it to form some stable product and releasing more amount of energy to the surroundings, that is what here, exothermic. So of course here always heat of hydrogenation is exothermic, but depending upon the substrate condition, sometimes it gives what, less amount of energy, sometimes more amount of energy, that is depending upon this substrate, so practically if you get here different values, now based on these values you may guess what kind of alkene it is, whether it is stable or unstable. So this is the factor. Now heat of hydrogenation is inversely proportional to hyperconjugation. So this is of course applicable for alkene only. Hyperconjugation okay, but here heat of hydrogenation of which one? Hyperconjugation of alkene, you may write directly here. Hyperconjugation of alkene, not carbocation, not carbon radical, because there is no addition of hydrogen for carbocation and carbon radical. Only it is applicable for alkenes. Now alkenes, one set of example like this, double bond is present. Now here two methyl groups are there. Next one is what here, double bond is as it is. Next here two methyl groups are there. Next one, double bond is as it is. There is no change in position of double bond. Here it is like this. Here it is like this. The last one would be like this. Now find out the alpha hydrogens. Find out the alpha hydrogens here. Find out the alpha hydrogens better. Find out the alpha hydrogens. Alpha hydrogens, hyperconjugative structure is directly proportional to alpha hydrogens. Here this is alpha hydrogen. This one will be alpha hydrogen. Here this one will be alpha hydrogen, alpha sp3, okay, hyperconjugative structure. Here how many are there? 1. Here how many are there? 1. So overall 2, 2, 3, 3, total how many alpha hydrogens? 10 alpha hydrogen. Here how many alpha hydrogens? 2 alpha hydrogen. Third one, here 1 alpha, here 2 alpha hydrogens. Overall how many alpha? 3 alpha hydrogens. Check it. Are you getting? Last one. Here 2 alpha hydrogen, here also 2 alpha hydrogen. So overall 4 alpha hydrogen. For example, this is the first molecule, this will be the second one, and third and fourth, So first thing we have to find the stability. Stability of alkene is directly proportional to number of alpha hydrogens, which means what is the order here? First one is more stable molecule than which one here? 2 alpha, 3 alpha, 4 alpha. Fourth one is second one. Next one is what here? 2, 3, 3. Next one is least stable reactant is what here? Second molecule. Least stable reactant is what here? Second molecule. Then tell me heat of hydrogenation. Heat of hydrogenation is inversely proportional to stability. Opposite to this one, which means here 1 lesser than 4, 4 lesser than 3, 3 will be lesser than what here? 2. Heat of hydrogenation is maximum for second molecule. Second molecule. So this is the application of heat of hydrogenation. So heat of hydrogenation is only applicable for which one beta? Alkenes, not for all. Alkenes hyperconjugative structure. Hyperconjugative structure. Okay. Second ones. Number of alpha hydrogens. Number of alpha hydrogens. 10 alpha, 2 alpha, 3 alpha, 4 alpha. 10, 2, 3, 4.